Hello students, I am Dr. Munir Omar with Database Management Systems. In lecture number 56, we studied about NoSQL. In that lecture, we had some basic concepts about NoSQL. Today, we will resume the same topic with some additional contents. In these contents, we have an important topic, that is gap theorem. We will also discuss that thing, and at the end we will have the comparisons between the SQL and NoSQL. So these are the contents for our today's lecture. First, we will look into the previous lecture. As you know that the previous lecture was about NoSQL, the basic concepts in NoSQL. Then we have a topic that is NoSQL is better for. It doesn't mean that NoSQL is better than RDBMSs. In some cases, RDBMSs are better, and in some cases, we may say that NoSQL is better. So we will look into those cases, or we will have those cases in which NoSQL is better. Then we have gap theorem. This is an important topic, and this is the base of NoSQL. So we will also study about gap theorem, and at the end, we will have a comparative study of SQL and NoSQL. So in the last lecture, we studied about big data. By big data, we mean a huge collection of data, or a big database for which a simple RDBMS may not perform well. So the example for big data is the data manipulated by social networks and search engines. So handling huge amount of data is also a big challenge, and this challenge must be addressed. Then we say that relational databases are backbone of business, but still the web-based application, particularly the social media sites like Facebook, Twitter, etc., these keep big data. They have a lot of information from the users, and they process bulky data in fraction of time. So managing such type of situation by relational databases is quite difficult, or it would not efficient, because the response time will be highly degraded due to the formalities or the constraints of relational databases. So in such type of situations, the NoSQL is preferred. Then we studied about the scaling. We have two types of scaling. The first one is vertical scaling. The second one is horizontal scaling. So by vertical scaling, we mean that we are upgrading our system. By horizontal scaling, we mean that we are installing some parallel systems. So if the data in systems is growing, so for that purpose, scaling becomes essential. Then issues with scaling up. Actually, we say that scaling up is an ideal situation for RDBMSs, because the entire database would be in a single server. So that would be a bit better situation for relational databases, while in case of the parallel systems, the performance of relational databases may degrade. So still, in scaling up, we may have issues. The biggest issue is that the database would be quite big. So executing or processing bulky data in a big database would also cause issues. Then we studied about NoSQL. By NoSQL, we mean not only SQL. It doesn't mean no and SQL. It's not no and SQL. It is actually not only SQL. This was first introduced by Carl Strozzi in 1998 in his file-based database, and later Eric Evan formally introduced it. Eric states that we must search for the alternatives so that we may address those issues which could not be addressed by relational databases efficiently. By NoSQL, as you know that we mean not only SQL. NoSQL is a non-relational database. There would be no tables, no relational models, no attributes, no schema. It is a kind of flexible database for real-time and big data applications. And we have multiple types of NoSQL databases. These types are document databases, key value databases, graph databases, white column store. Then we studied about the features of NoSQL. There are many features of NoSQL. So some prominent features are non-relational, schema-free, and distributed. We studied about these all in our previous lecture. Now we are moving towards our today's lecture. Okay, let's start with our today's topics. So the first is when will be the NoSQL better for? We can say that in which conditions the NoSQL is better. If somebody says that NoSQL is taking the whole industry, then he might be wrong. There are a lot of situations and applications where the relational databases are the obvious tools as compared to NoSQL. Both the RDBMSs and NoSQL are useful, and they are gonna be useful in future. So we have already discussed the big data in our previous lecture. NoSQL are efficient to handle lots of data as compared to relational databases, because in case of NoSQL we don't follow some formalities, and while relational databases follow some strict constraints which degrade the performance or the availability of information for users. Another huge advantage is its data models, which are extremely flexible. So, all right, look at relational databases. Let's say MySQL. We have to go through some predefined schema. While creating a database in MySQL or any other relational database management system, we need to define everything, the attributes, their data types, their constraints, etc. Means we need to define the entire schema for database. While in case of NoSQL, these things are quite flexible, and in some situations we don't define anything in the beginning. The next advantage is the advantage of data structure. It continues with the previous point, that is no predefined schema. No need to define your tables or columns, the data types, whether it is varchar or integer. You don't even know the data structure of objects used in your database. It would be completely dynamic data model in case of NoSQL. NoSQL databases are cheaper to be managed as compared to relational databases. There is less need of multiple system admins. There's not as much to do. There's not as much to manage as compared to relational databases. Also, scaling. Scaling is a huge advantage of NoSQL. It uses horizontal scaling or scaling up. We have already studied these horizontal and vertical scaling. So the NoSQL is using horizontal scaling, while the relational databases, they use vertical scaling. Scaling is extremely important in the prevailing industry, as it is continuously growing, and horizontal scaling is much convenient and cheap and feasible for the software industry as compared to vertical scaling. And this is a big advantage for NoSQL. So these were the advantages of NoSQL or relational databases in some special scenarios. Now we are starting with CAP theorem. In distributed systems, there might be various properties, but here for CAP theorem, we are supposing three major properties. Though these are consistency, availability, and partition tolerance. So we have consistency, availability, and partition tolerance. The CAP theorem is about these three major properties of distributed systems. The main focus is about the databases, and we can say that in these distributed systems we are sharing data. So by consistency we mean that all the copies have same value. In distributed systems we may have multiple copies of data, so we must assume, or we must say that these copies must be similar. For example, if we have x equal to 5 on one server, then on second machine the value of x would be 5. So this is called consistency. Then the second thing is availability. By availability mean that the systems must be always available 24/7 to the user, and all the requests must be fulfilled. The read and writes always succeed. And the third thing, or the third property of distributed system is partition tolerance. The consistency and availability hold even when network failure prevents some machines from communicating with others. We have a network failure, still the system must work, and still there will be consistency and or availability. Actually, we may have our data stored on multiple servers, and let's say the network breaks, the intercommunication among these systems break, then still the entire system or the services will work. Still there would be consistency of data, and still there would be availability for user. The CAP theorem is also known as Brewer-CAP theorem. It states for any system sharing data, it is impossible to guarantee simultaneously all of these properties. These properties must be guaranteed, but it is not possible for a system to guarantee all these three properties all the time. So this is the main thing in Brewer's CAP theorem. You can have at most two of these properties for any shared data system. Actually, we must put priorities to these three properties, and the main focus would be to fulfill at least two among these three. Very large system will partition at same point. That leaves either consistency or availability to be chosen. In traditional database management systems, we prefer C over A. We prefer consistency or availability. The availability is on second priority. The foremost priority is consistency, and also the partition tolerance in relational databases. In almost all cases, you would choose A or C. In case of NoSQL, we prefer availability or consistency. So the first thing is availability, and the second thing, if we achieve availability, then we care about the consistency. We may have some specific applications in which we may require the consistency, but in general, for NoSQL, the foremost thing is availability of services to the users. By availability, we mean that the user can access the services. The data or queries of users are processed in time, and there might be some inconsistent data, but the foremost thing is availability. The system must be available to the users. So in CAP theorem, we have three things: consistency, availability, and partition tolerance. All clients have the same view of data. This is consistency. It means that on all the systems, on all the machines. We have distributed system, so we will have different systems, we will have different machines interconnected. So on all the machines, the data would be similar. The client will have always the same view of the data. Consistency. Here we have two types of consistency. The first one is strong consistency, and the second one is weak consistency. By strong consistency, we mean the asset properties. We have already studied this asset in our previous lectures. This was actually in the transactions topic. By asset, we mean atomicity, consistency, isolation, and durability. Then we have weak consistency. By weak consistency, we mean basically available soft state eventual consistency. Eventual consistency is a weak guarantee. Here, by basically available, we mean basic reading and writing operation are available as much as possible to the user, but without any kind of consistency guarantee, or without the guarantee of any consistent state of data. So here, in simple words, we can say that the foremost thing is availability, and then we we think about the consistency. So the consistency might be not strong, but the system must be available in the case of base, or in the case of weak consistency. Usually this weak consistency is followed by NoSQL. The relational databases follow the asset properties, while the NoSQL follow the cap theorem. In case of asset properties, a database management system is expected to support asset transactions. Uh, Means that there would be atomicity, consistency, isolation, and durability. By atomicity, we mean that either the entire transaction should be processed, or none of the transaction should be executed, either 0% or 100%. By consistency, we mean that only valid data should be written. There shouldn't be any inconsistent data in the database, or the state from one consistent to another consistent should be changed. The transition between two states should be in a way that the second state should be in a consistent state. Then we have isolation. By isolation, we mean that one operation at one time. If there is an operation, then that operation should be isolated from other. And by durability, we mean that once the operations are committed, then there would be permanent change in the database. By Cape theorem, we have consistency. By consistency, we mean that all the data on all the clusters or machines must have the similarity. And by availability, we mean that all the systems must be available for reads and writes, or simply we can say that all the systems must perform and be available, and the users must be given the services all the time. By partition tolerance, we mean that there should be guarantee that if there is a problem in the network, still the system must work. Now let's consider an example. Suppose we have two systems, and on both systems we have a single database. Both systems are interconnected. We can say that we have a database on two interconnected systems, and on both systems the data is replicated. Here we have name equal to, let's say, Ali, and on second system name is equal to Ali. I mean that for a particular item, the name is Ali on both systems. Means that the data is consistent. Then two users, A and B, access this data on these two systems. Let's say A is accessing data on one system and B on another system. Both are accessing this item where name is equal to Ali. Now A writes something here, and let's say it changes this name to Ali Khan, while B reads this item as Ali. Now here we have questions. Does B see the write from client A? When B was reading this item as Ali, did B see the change as this was changed by A as Ali Khan on another system? Now this is a kind of trade-off between the consistency and availability. For NoSQL, the answer would be maybe. Now depends. If the priority is availability, then definitely B would see it as Ali, not Ali Khan. But if we are putting consistency as our foremost priority, then this item would be immediately changed and the new replica would be given to B instead of the old inconsistent or the previous value of this item. Cape theorem states strong consistency can't be achieved at the same time as availability and partition tolerance. So if we are achieving availability and partition tolerance, then we cannot achieve the strong consistency. This is the main thing in Cape theorem. We have eventual consistency, which we studied in base. When no updates occur for a long period of time, eventually all updates will propagate through the system and all the nodes will be consistent. As it is hard to achieve on cloud computing. Moreover, it is not always required. For example, for blogs, for status updates, for product listing. For example, on social media, let's say Facebook, I put a status XYZ, and this XYZ can be accessed by millions of users at the same time, and this would be most probably due to access requirement. This might be replicated on many servers, and after some time I change this status to WXYZ, then it is possible that some users get the older status instead of this new status for a chunk of time due to the eventual consistency or due to base or due to Cape theorem. Cape theorem, next thing is availability. Each client always can read and write. We have already studied this thing. And the last thing is partition tolerance. A system can continue to operate in the presence of network partitions. If there is any failure, still the system will work. So the system is not fully dependent on all the machines involved. If some machines are not available, there might be some failure or any issue in the network, still the database would work, still the data would be available to users. Now the last thing in our today's lecture is the differences between SQL and NoSQL. So the first thing is definition. By definition, the SQL are known as a relational database management system or relational databases, while NoSQL are called as non-relational or distributed databases. The traditional databases use SQL syntax and queries to analyze and get the data for further insights. They are used for OLAP system. By OLAP, we mean online analytical processing. NoSQL database system consists of various kind of database technologies. These databases were developed in response to the demands presented for the development of modern applications. You will find lots of standards or types of NoSQL databases. In RDBMSs, we have a standard language SQL, while in case of NoSQL, there would be different syntaxes. Then we have the query language. SQL is used. We have structured query language for traditional databases, and in case of NoSQL, no declarative query language is used. SQL databases are table-based databases. We have attributes in these tables, while in case of NoSQL databases, these are document-based, key-value pair, graph-based, and white column-based. We have studied these types in our previous lecture. The SQL databases have a predefined schema, while in case of NoSQL, there is a sort of dynamic schema for unstructured data. For scaling, SQL databases use vertical scaling, or we can say that vertical scaling is better for SQL databases, while in case of NoSQL, horizontal scaling is better or more feasible. Examples, we have Oracle, Postgres, and MS SQL. For NoSQL, we have MongoDB, Redis, Firebase. There are lots of NoSQL databases. SQL are good for complex query intensive environment, and these NoSQL don't fit in complex queries. SQL are not suitable for hierarchical data storage, while NoSQL are more suitable for hierarchical data store as it supports key value pair method. Then variation, you will find minor variations in SQL. As I told you that there is a standard language, structured query language for all the traditional databases. So in most of the databases, whether it is Oracle, it is MS SQL, it is MySQL, there would be sort of minor variations. These are almost similar, but in case of NoSQL, there are many different flavors and many types, which include key value stores, document databases, and graph databases. The SQL are developed earlier in 1970s, while the NoSQL were developed in late 2000. They were introduced in 1996, but properly started in 2000. SQL are a mix of open source. You can find open source databases and also proprietary databases, while NoSQL are open source. In SQL, the foremost thing is consistency. So these are configured for strong consistency, while in NoSQL, these may offer strong consistency and in some cases weak consistency, depends. The relational databases are suitable for solving asset problems. Actually, the relational databases, the SQL, follow the asset properties, while the NoSQL, these are mainly focusing on the availability of data, not the consistency. Then we have two things, the asset and base. We just studied these things in our previous slides. So SQL supports asset, while NoSQL has base. In SQL, we have atomicity, consistency, isolation, and durability. While in NoSQL, we have eventually consistent but basically available systems. So this was all about NoSQL. The main topic in this lecture was cap theorem, and then we looked into the differences between the SQL and NoSQL, and also in the beginning we studied that in which cases NoSQL is better than SQL. Thank you.